What we have in Surface is a vision system, and the idea is that rather than having something that responds to pressure or sound or capacitance, if we can see all the things on the surface, we can be extremely versatile.
The Surface Vision System we typically track and deliver to application programs 3 different kinds of contacts. There's finger contacts, we put generic shaped things down. What gets returned to a program typically is just an ellipse with a major and minor axis. We also track these special tags, which we can give some very precise information about in terms of rotation and location.
Here's a camera with and without its lens. You can see the sensor that picks up an image of roughly 1/4 of the screen. So this is one very bright infrared LED. It's multiple watts of emitted power. It's quite safe because it's under a diffuser. Because it's just a single source, gives us a very crisp view of what's going on the outside. It's all about how reflective the things like your finger or our tags are sitting on top of the surface that is picked up by this camera, and then the 5 cameras that are all underneath the surface where you can't see them combine their data through a special custom board that we've built called a DSP board.
The vision system compiles the images together that it sees, and it bubbles them up in terms of useful data for applications to consume. You can see that there's an image of my hand, and you can readily tell that that's an image of a hand. Likewise, I can take a dollar bill and I can set that down, and it's pretty obvious that that's a dollar bill. So it's good enough resolution to make some determination from the visual patterns that we're seeing.
So the first thing we have to do is to take the images from the camera and normalize them. That is to basically stretch out the distortions that are caused by having 5 different lenses, stitch those images together and equalize the light levels. Then we have to figure out what the different things on the surface are. They might be fingers, they might just kind of be objects like a paintbrush, or what we call a blob, or it could be tags, either higher resolution or low resolution tags. So we use the power of the GPU, that's the graphics board that's in the processor, to make multiple passes through that image to look for specific aspects. Like if it's a tag, it'll have a dot that's an exact size, and we know exactly how big that's going to be. So we have fast algorithms that look for exactly that.
And we can take that pattern and we can use that to detect whether or not a finger is touching. We can also do that with other kinds of patterns. So one example to illustrate this is you can see that dice have a pretty consistent pattern that they have. The cameras can see that there's a pattern here that we would recognize as a 2. So we know there's a 5 on the other side. We can take that same concept though and use a consistent visual pattern and get some kind of useful data that we can bubble up to applications and users. So for example, here I have a visual pattern that doesn't make much sense to the human eye. You can liken it to a die, but it's obviously much more complex than that. But it's something that a computer can easily recognize and see consistently.
The amount of data coming out of the cameras is extremely high. It's well over 100 megabytes per second coming off of the 5 cameras in total. That's too much to be processed by a normal application, written in C++ or C# or what have you. What we try to do is to strip away the parts of the image that aren't moving, and then look at the parts that have changed in order to determine what those objects are. And then if we simply pass the application the information about an object, it's located here, its orientation, its tag identifier, something like that, that's just a couple of bytes, as opposed to the entire image, which is going to be many hundred kilobytes every single frame of information that comes in. So we get massive reduction by doing object analysis before we send the information to the application.
Taking that image and processing it and using software to determine the visual patterns that are in there is an expensive operation. and it's something that the vision system is tuned to do, and that application writers are not necessarily want to burden themselves with. So by bubbling up this lightweight, useful data, we give application developers the majority of what they need to write really cool applications.
The other upside is that the applications all then can respond in the same way.
What this little guy is he could just be any sort of toy or object, but what I wanted to do is try to project from the surface, just using optics, onto his face. And so I could basically skin a toy and make it talk or make it do whatever I wanted. So I took one of these little cheesy fiber optic lights that you see, get for a couple dollars or whatever. Put a clear tag on the bottom so the surface could track where it is, and then I place it down. So basically, just through the surface and not through any mechanics or batteries in this toy or device, I can, pretty much skin it how I want it. So here's his little eyeball, and as you rotate him, he stays, oriented. Notice, like, if I pack him tight like this, it gets brighter. If you packed them much tighter and had more, you could get a pretty good image into a toy or into any object.
We did a series of experiments with the raw image. First thing we developed was this heat map. By taking the grayscale parts of the raw image and creating little colored tiles based on how dark that was. That led us into thinking about using that information to determine the raw shape of an object. See, here I'm able to track pretty well the shape of any object at all. And we actually create a vector set for this so we can do hit testing and other activities with this. Any organic shape. We call that contact geometry. So this is something that you could really only do with the vision system, because it starts with being able to take essentially a picture, that raw image, and then analyze that raw image for the shape of anything that's touching the surface, no matter how many points of contact it has or what the shape is, or organic or otherwise. Set some cups down here. You can see these objects interacting now with the shapes. So we combine that idea of interacting with shapes with actual contact geometry shapes and created this little program where we can draw, but these things that I draw will sense the contact geometry of anything that's placed on the surface and follow it. So now, instead of just tags and blobs and fingers, we have full contact geometry of the shape of any object that we can do hit testing with, and in this example we're just following the vectors that have been traced out by the shape.
The most likely scenarios where you'd want to use raw data, raw image data in an application are either that you're looking for a very particular shape that is specific to the application. Maybe there's some big star shape that is part of a game or what have you that you're putting in. Or the other alternative is where you have what's called a pixel shading environment, basically where the picture of what is being put on the surface is directly being used by the application. You can see examples of that where we have applications that display what amounts to a raw image coming back from the camera. Or if you take something like water or what have you, where you want to interact between the image coming back directly and the image with the image being displayed, so that there's no kind of analysis being done as to what is on the surface. It's being used as a raw picture.